Welcome to the course on Fundamentals of Wireless Communication. In today's world, wireless communication is no more a fancy, it has become a necessity. It is facing also a great challenge of meeting the basic needs, even to provide connectivity, high data rate and reliability in terms of always connected services. MIMO communication holds the key to providing solutions to almost of these problems. MIMO communication has contributed so much in the last few decades that it has become a subject in itself. MIMO is used in almost all broadband wireless communication technologies such as WLAN, WiMAX, LTE and others. It is providing data rate increment over single antenna systems in multiple folds in orders of 4, 5 or 10 as a factor. The 5th generation wireless communication technology is expected to be based on MIMO communications amongst many other possible solutions. Why multiple antennas? MIMO is the acronym for multiple input, multiple output. The use of multiple antennas in wireless communication opens up a new dimension, that is the space dimension. MIMO communications is all about using this extra dimension beyond time and frequency, that is space, to help enhance the quality of service, data rate, coverage, outage and many other performance metrics of typical wireless communications. It is used to increase data rate by multiplexing. It is used to increase quality of service by providing diversity as well as coverage by providing array gain. MIMO OFDM is a very fundamental, very strong technology which is the backbone for LTE, also known as the 4G, Wi-Fi 802.11n and beyond, WiMAX amongst many others. In this course, we will cover the important aspects of MIMO communications such as computation of capacity, error probability calculations for MIMO techniques, transmitter and receiver design and multi-user communication. After completion of the course, the participants will be able to apply these methods for performance analysis and design of advanced and complex wireless communication system. When we look into multiple antennas, one of the first most important benefits that is seen is spatial diversity gain. The diversity, as the name implies, provides gain due to variation of signal strength received in multiple antennas. It helps us overcome small scale fading as well as path loss by using the multiple antennas in a very intelligent way, combining the signal depending upon the signal situation and providing appropriate gain benefit. The next very important gain provided by MIMO communications is increase in capacity through spatial multiplexing. As shown in the figure, 2 users can simultaneously communicate with the base station. The curve on the right hand side indicates the increase in capacity as one keeps on adding different number of antennas to the communication system. The next benefit that MIMO brings is through beamforming. The beamforming gives us the facility to reduce interference as well as to provide space division multiple access and many others. In LTE, MIMO is used in different ways. It is used as single input multiple output, multiple input single output and multiple input multiple output. It can be used for diversity, it can be used for spatial multiplexing, it can be used for single user MIMO, multi-user MIMO, open loop multiplexing as well as closed loop multiplexing. In a typical single user MIMO, the time frequency grid, which is usually viewed in a broadband wireless communication system that is used to provide services or which serves as a basic resource unit, is incremented by providing another layer on the same time frequency grid, providing facility to transmit data simultaneously in the same time and same frequency on 2 different streams. In other words, 2 different data streams can be transmitted on the same time and frequency using multiple antennas at the transmitter and at the receiver. A typical single user MIMO open loop spatial multiplexing scheme is depicted in the figure, where serial data is first converted to parallel so that they can reach the multiple antennas, and then they are radiated through the air, it is received at the receiver, and advanced baseband signal processing is done. In a typical closed loop system, similar process happens as in closed open loop at the transmitter, but at the receiver the channel state information is computed and fed back to the transmitter, which again pre-codes information before sending it back to the receiver. This helps in improving the performance beyond open loop communication system. In a multi-user MIMO is one step beyond single user MIMO. The time frequency grid, as in a single antenna system, is used to communicate between the transmitter and the receiver for carrying data information. Multiple antennas, as in single user system, is used to carry different data streams from one user, but on top of it additional layers can be used to transmit different users' data at the same time and at the same frequency. A typical multi-user MIMO communication system would look like a base station having multiple antennas and multiple receivers having multiple antennas communicating with the base station. Similar structure follows as in SU-MIMO at the transmitter. From the base station, when signal goes to the receiver, in many cases you require a feedback from the receiver to the transmitter for proper operation of such systems. Going ahead further in this figure, as can be seen, the 1x1 indicates the system performance or the capacity in bits per second per hertz for a single input single output system, which is typically available in a general wireless communication system. As we can see, as we increase the number of antennas as shown in this particular result, which uses 2 transmit antennas, 1 receive antenna, there is slight increase in performance, and then as we go ahead increasing the number of antennas, as we see here 1 transmit, 2 receive, there is further increase in capacity. 2x2 means 2 transmit, 2 receive, and 4x4 means 4 transmit antenna, 4 receive antennas. It gives a huge jump in the capacity over a SISO, that is a single input single output system. This is a major reason why MIMO has become so famous and is used in almost all broadband wireless communication technologies to provide extremely high throughput. We take a look at how the single user and multi-user MIMO look like and what brings in the capacity gain. Typically, the transmitter and the receiver is equipped with multiple antennas, and the signal from one of the antennas is received by all the receive antennas. Signal from the other transmit antenna is also received by all the antennas at the receiver. Such a system can be modeled using a baseband channel model and indicated by channel coefficients, which we will see details in later part of the course. Through advanced processing at the transmitter and at the receiver, such a network of signal flow can be broken down into interference free parallel data streams, where the signal from one stream does not leak into the second data stream. When this is achieved, 3 independent streams as shown in this figure can be transmitted from the transmitter to the receiver. One of the important part of the course is to understand how such a system can be achieved and what kind of benefits or what kind of increase in capacity can be achieved through such a configuration. Moving ahead beyond single user MIMO, as we look at multi-user MIMO, the receiver is now split into multiple receivers pertaining to different users. Going beyond, at the transmitter, similar thing can be done as done in the receiver, where the transmitters are also now separated, but they are connected through some back plane, and such configuration is known as multi-point transmission to multiple users, which is a typical scenario as used in modern cellular communication system. If we look at the structure of a typical cellular communication system, there is a base station equipped with multiple antennas, then there are multiple users all around, and the base station antenna is used to provide either single SISO link or multiple links. The number of links can vary simultaneously. So, there is a whole lot of signal flow that happens between the base station and the user equipment, and they can operate in single user mode, multiple user MIMO mode, beamforming mode, diversity mode, that depends upon the controlling algorithm at the base station. Similar thing happens at all the neighboring base stations. In a typical multi-point transmission, these base stations are coordinating with each other and they send joint signal to these users, so that instead of interfering, they add the signal in such a way that there is net increase in system performance, that is in terms of capacity and reliability factor. We will also try to cover such schemes in the course. The next important thing, which is an extension of the earlier methodology, is coordinated scheduling with RRA, radio resource allocation, which uses all the previous techniques, single user and multi-user MIMO, beamforming, diversity, along with which the radio resource allocation, that is the time frequency grid, is also combined in the resource allocation problem along with MIMO, and the joint allocation resource allocation problem is solved. This is a typical state of the art that is used in present day communication system. So, with this brief overview, I would like to communicate that we would like to cover all these aspects through which we will be able to learn how a typical advanced MIMO wireless communication system work, how can such philosophies be used in designing even newer and improved systems, where today we are coming up with massive MIMO and even beyond systems. The typical syllabus that will be covered is already available in the website, but still we take a look at it. Initially, we will be spending some time on understanding the channel models that are available for MIMO communications. Then we will look at typical MIMO signaling techniques as briefly shown in this video. We will spend time on capacity computation, which is one of the most important parts of the syllabus, error probability calculations, which helps in improving reliability, space-time coding techniques, diversity and multiplexing trade-off, because these are the two important gains that MIMO provides, and finally taking a look at multi-user MIMO. Some of the reading resources are presented here, where initially we will be spending some time on the propagation from this particular book, and the main book that we will be following is Introduction to Space-Time Wireless Communication by Paul Raj, Rohit Nabar and Dhananjay Gore. We will also be referring to elements of information theory. There are a whole lot of other books also available. As and when it is necessary, we will be providing you with the appropriate information. So, welcome to the course on fundamentals of MIMO wireless communication, and hope at the end of the course you are able to design an advanced MIMO communication system. Thank you.